We're going to dive into some special right triangles. These triangles, as we can see, are all equilateral triangles. The one on the left, its sides are 2, 2, and 2. The middle one, 4, 4, 4, and the right one, 6, 6, 6. And we're going to use these equilateral triangles to come up with some ideas on special right triangles, our 30, 60, 90 case. So let's take a look at this one on the left. All of our angles, because this is a right triangle, or excuse me, an equilateral triangle, as all of the sides are the same, we know that all the angles are the same. If all the angles are the same, then if we take 180 and divide it by 3, we end up with 60 degrees for all of our angles. Not those angles, excuse me, but these angles here. This entire angle would be 60 degrees, and then this angle would be 60 degrees. So all three of those those angles on our big triangle on the outside are going to be 60 degrees. Now, if I look at this line drawn down the middle, okay, um, I'm going to let you guys know that this is in median, this is an angle bisector, this is an altitude. A lot of the terms that we use at the beginning of the year, but essentially this line segment is meeting the base at a 90-degree angle, and it's cutting that top angle in half, that angle where angle A is. So I'm actually going to delete this 60, and I'm going to go on ahead and say that angle A is 30 degrees, as well as this angle over here on this side. So if I look at this, our angle measures are going to be 30 degrees, 60 degrees, and 90 degrees. Another way I can come up with that is I know that angle A plus angle B plus angle C all add up to equal 180. I know that angle B is 60. I don't know what angle A is, but I can work on this. Angle B I know is 60, and angle C I know is 90. They all equal 180. 60 plus 90 equals 150. So angle A plus 150 equals 180. Subtract 150 from both sides. Angle A equals 30 degrees. So that confirms that angle A does in fact equal 30 degrees. Okay. So if I've got all that information, I'm then going to look at my side measures. Okay. So angle C is down here where the 90-degree angle is. That is going to be across from this 2, which makes little c, side C, 2. Okay. I'm going to go with A. I'm going to look at A now. And A is across from 30 degrees. Well, this piece right here, okay, is going to be halfway across this equilateral triangle base, which makes this one and this one. I only need to know the left-hand side. Little a is going to be 1. And what I need to do, what I'm looking to do here, is solve for little b, okay? So I've got 1, I've got 2, and I've got little b that I'm looking for. So let's take this information, okay? We can use Pythagorean theorem to help us with this. We've got side A, which is 1, we'll square it, plus b squared equals c squared, which is 2 squared, okay? And what I'm looking to do is I'm going to solve this for b just like I would doing anything else. So 1 squared is just 1. B squared equals 2 squared is 4. What I'm going to do here is I'm going to subtract 1 because I am looking to isolate b squared. So I'm going to subtract 1 to get b squared by itself. B squared equals 3, and then I am going to take the square root because the inverse operation of squaring a number is square rooting a number. Okay, b squared will be b, and then the square root of 3, if I do the birthday cake method, all I have is 3 underneath. So the square root of 3 is going to be what we get for little b. Okay. I'm going to use this same process to work down my other questions. I'm not going to go through the big lead up. I'm going to go on ahead and assume 30 degrees, 60 degrees, 90 degrees, just like we had before. I'll go on ahead and do that over here, 30, 60, 90. Okay, so if I've got that, all right, and based on the information that I found earlier, I know that C is 4. I know that A, keep my colors the same, A is going to be half of 4, which is 2, and then I'm going to solve for B. So I take 2 squared plus B squared equals 4 squared. And I work this down. 2 squared is 4 plus B squared equals 16. Okay. I'm going to subtract 4 because, again, I want to get B squared by itself. So B squared equals 12. And then remember to get B by itself, because I don't want that squared anymore, I need to square root it. And if I do something to one side, I have to do the same thing to the other. So I'm going to end up with little b equaling, I do need to do the birthday cake method here. So I'm going to take 12. The smallest thing I can divide it by is 2, which gives me 6. The smallest thing I can divide 6 by is 2, which gives me 3. Small thing I can divide 3 by is 3, which gives me 1. I'm left with a birthday cake on top. I can pull a pair of 2's out front. I'm left with 3 times 1 underneath, which is simply root 3. So I end up with 2 root 3. I'll clean that up a little bit. 2 root 3 as my answer. I'm starting to see a little bit of a pattern. I do want to confirm this before I go on ahead and say that this is the rule I'm going to follow. So across from C is 6. Across from A is going to be half of 6, which is in fact 3. And then I'm going to solve for B. So I have 3 squared plus B squared equals 6 squared. When I work this down, 3 squared is 9 plus B squared equals 36. And then I'm going to subtract 9 because, once again, just like the other 3, I want to get B squared by itself. So I subtract 9. B squared equals 27. And in order to get B by itself, just like I've been doing, I need to take the square root. 27. Smallest thing I can divide 27 by is 3, which gives me 9. I can divide 9 by 3, which gives me 3. And then I can divide 3 by 3, which gives me 1. A pair of 3's brings a 3 out front of my square root. I'm left with 3 times 1 underneath. B equals 3 root 3. And what it looks like is I have developed a rule that I will be able to use for 30, 60, 90 triangles. Okay, there is a ratio where the smallest side is half of the largest side, the hypotenuse, or the hypotenuse is twice as much as the smallest side. And then if you pay attention, you can see it a little bit more in the middle and right one, but if I add that 1 in front, okay, all I'm going to do is multiply my small side, my small leg, by square root 3 to get my long leg, okay? So in the first example, I had 1, square root 3, 2. In my second example, 2, and then I add a root 3, so 2 root 3 for my long leg, and then 2 times 2 is 4. For my one on my right, 3 was my short leg. I add that root 3 for B, my long leg, so 3 root 3. And then for my hypotenuse, I take my short leg 3 and multiply it by 2 to get 6. That is going to be the rule that we follow. We do dive into that in the next slide. So be looking at that. And if you have questions, be sure to go through it, go slow, take your time if you really want to understand a little bit more on how to develop these 30, 60, 90 rules.